Hello and welcome to the Center for Military Modernization and Warrior Maven. My name is Chris Osborne. A very significant opportunity today. The center is talking with General John Rafferty. Now, he is the director of the Army Futures Command cross-functional team for long-range precision fires. Extremely significant program looking at long-range weapons, artillery, different kinds of guidance technologies. So let's welcome General Rafferty. Thanks so much for your perspective, sir.
Hey, thanks, Chris. I'm thrilled to be here. Warrior Maven's been a great venue for us to tell our supporters out there what we're doing and to tell the American taxpayer what we're doing with the resources that we've been given.
Well, that means a lot to us, General. Thank you so much. Well, I recall us talking at length about things like AI and a lot of questions I want to ask you about targeting and data processing. But I thought it might make sense to start with something you teased me a little while ago about the shape trajectory being one of my favorite programs that you're working on. And sure enough, isn't that an example of innovation integrating with real cutting edge, potentially near term applications? And when you look at something like Ukraine and the amount of mobile launchers, the ability for a 155 to shift or adjust in flight to go after a moving target, I have to think that's paradigm changing. So, A, what are your thoughts about this round and how's it going?
Yeah, so you're right. We want to get to the point where we have target seeking munitions, and there's counterintuitively it lowers the cost per kill. Right, those will be expensive munitions, but when you have the confidence that it's going to seek and destroy the target that you're shooting at, it certainly lowers the number of munitions you have to shoot at it. The other part of it is it helps to shrink the sensor to shooter timeline, because you need a certain level of fidelity. You need to know that the target is what you think it is, and the location. But you may not have to have all the specifics that add extra time, extra tasks for analysts, and we can close that sensor to shooter loop in a much more timely fashion, which is so important. But these target seeking munitions require projectiles that can course correct, and so the agility that our industry partners and our Army engineers have shown in trying to get the most out of currently fielded projectiles. So one of the what I was joking before, at one of our recent conversations about your interest in the Excalibur projectile is a great example of that. Let's see what else can be done with this very capable projectile, and let's see if we can shoot it farther, and then let's see what we can do with the trajectory to get the most range out of it. Can it withstand greater chamber pressure and higher G loads for increased muzzle velocity that will get that extra range? And then can we, with some software updates, adjust the flight trajectory so that we can get increased range? And the answer has been yes. We've been able to do that and extend the range of the currently fielded Excalibur. We're going to get that out to 70 kilometers, and then that's helping us with an enhanced lethality version of the Excalibur called Excalibur Hit to Kill that'll have that target seeking sensor and get out to those extended ranges. Using maneuverability is the right term, not mobility, but maneuverability to course correct and steer towards the target to destroy it.
I know with something like Excalibur S, that can be done with laser spotting, but how, again, I know we've spoken about this, does the shape trajectory, is it an IMU, is it an active seeker that sends a ping forward like an SM6? How does this shape trajectory adjust in flight?
So I won't get into the specifics of the seeker, right? Because that's obviously something that we want to protect. But the projectile itself has fins and canards that enable it to steer. Now, it has limitations, right? So what our engineers call maneuver authority, but so that maneuver authority is limited, so that helps you determine what we're referring to now as a basket for where that, that target might be. If it's in that basket, then the projectile should have enough maneuver authority to make the adjustments to get after the imprecisely located or moving targets with a degree of precision necessary to destroy it.
Well, I remember, General, it almost blew my mind, the idea of an Excalibur round, having followed artillery for a few years, to shape course in flight and essentially knock out an enemy vehicle, either under a bridge on the other side of a mountain. You can't help but think about tactically how much that might change the equation. You mentioned long-range projectile, and IRCA and the Excalibur filed extended range cannon artillery. That's another massive breakthrough program. Last I wrote about it, it was 60 to 70 kilometers ranges. What's the latest there?
Yeah, so the extended range cannon artillery system is just that. It's as much as about the projectile. We talked about one of them just a moment ago, as it is about the platform, the propellant, the course correcting fuse associated with delivering this capability, and the howitzers are being produced by the Army Organic Industrial Base. So this is a really big Army success story here that we're building on the M109A7 PIM chassis. So that's the upgraded chassis that's being produced right up the road here from Fort Sill and Elgin by BAE Systems. And on that chassis, we're putting a new turret with an upgraded armament system. That armament system pulls out the 39 caliber length gun tube and puts in a 58 caliber gun length. And that basically takes a gun tube that's 20 feet long and changes it to 30 feet long. It takes out the interrupted screw breech, which is a pretty intricate, almost like a Swiss watch type of breech. It closes and then turns to seal and replaces that with a sliding block breech, which is a lot more like a tank breech. It's a big fixed, very robust metal breech that basically just slides straight up and seals the back end of the cap of the cannon in the chamber with this sliding block breech. So that big robust breech, that larger chamber, gives us the ability to develop a supercharged propellant that's much longer with different propellant grains that generates much more chamber pressure and then pushes the projectiles out with greater muzzle velocity, and that's how we can achieve the longer ranges. The system is going very well. What we're doing is developing each one of these concurrently. The howitzer system, the propellant, the projectiles, the course correcting fuses, and that means the concurrent development is very challenging. Everything we're doing is a prototype, right? So it's test, fix, test. And every test, fix, test changes and affects every other component of the system. So I try to look at that. There's a lot of advantages that come from that. One is we can move faster, and it brings our team together on an absolutely daily and hourly basis. Whether it's at Yuma where the testing's going on, or it's at Picatinny, or it's in Detroit, wherever it is. But right now we've got the platforms. The cabs are being modified at between Anniston and Letterkenny Army depots. The gun tubes and armament system are being developed at Watervliet Arsenal. And then they're all being assembled at the Picatinny Arsenal and then shipped out to Yuma proving grounds where they go into swim lanes of testing. We've got 6 prototypes right now. We'll have 18 ready by the end of next fiscal year for delivery to a battalion at Fort Bliss, Texas, where we'll go into a 1-year operational assessment. That's a long answer to a short question, but it's going well. However, it's not without challenges, right? I mean, there are still every day we're encountering challenges in this test, fix, test process, and every day we're fine tuning the schedule for test assets, for range time, for testers. So we're working very closely with the Army Test and Evaluation Command which headquartered out of Aberdeen, but they run the Yuma Proving Grounds, and our teammates at Yuma are, we're lucky to be the number 1 priority, right? So they absolutely prioritize our efforts, and we're very fortunate in that way because there are, that place is a national asset, and we're lucky that we're on the top of their list because they're bending over backwards to accommodate the schedule and know the importance of this system. And we got a battalion of soldiers that are going to be waiting on these systems, so we got to be ready.